Hey everyone, and welcome to this explainer. Today, we're diving into something truly mind-bending. We're looking at a remarkable piece of source material that maps cutting-edge astrochemistry straight onto the linguistic structures of ancient texts. It's called the cosmic grain. So let's jump right in and explore how the death of stars might actually be the very seeds of life.
Right off the bat, we're faced with this massive mystery box of a question. What if the chemical ashes of dead stars are actually the seeds of new life? You see, in astrochemistry, when a star dies, it ejects these massive amounts of carbon-based molecules deep into space. Now, for a really long time, standard materialist science looked at these ejections and said, okay, that's just random cosmic debris. Essentially, chemical garbage, right? But the data we're looking at today poses a totally different, fascinating question. What if this debris isn't the end of a cycle at all, but rather a meticulously structured beginning?
To really wrap our heads around this, we've got to introduce the two brilliant minds at the center of our source material. They both work at the U.S. Institute for Astrochemistry and Origin of Life. On one side, we have Dr. David Thompson. He's a staunchly materialist astrochemist. His perspective is pretty straightforward. He sees these organic molecules as just random chemical garbage left over from a dying star. But then, on the exact opposite side, we have the lead infrared spectroscopist, Dr. Mariam Al-Qurtubi. She looked at the exact same telescope data, but she approached it with this radical hypothesis inspired by verses from the Quran, specifically Surah Yasin. She suggested that, hey, maybe these molecules aren't garbage at all. Maybe they're highly organized cosmic grains, or seeds. Okay, so what exactly are we talking about here? The molecule at the center of this whole debate is called a polycyclic aromatic hydrocarbon. We'll just call it a PAH for short. Using data from the Spitzer and James Webb Space Telescopes, Dr. Merriam analyzed how these incredibly complex interstellar organic molecules actually emit light in the infrared spectrum. Basically, they show up as these distinct bands of light between 3.3 and 11.2 microns. And guys, this right here, this is the hard, empirical data that forms the entire foundation of what we're looking at today.
So where does the ancient text come in? Well, Dr. Mariam used a very specific structural framework to analyze all that telescope data. She drew directly from Surah Yasin, verses 33 through 35. These verses talk about a dead earth being brought to life, and from that, grain is extracted for sustenance. It mentions gardens of date palms and vines being created, springs flowing, and fruit that isn't made by human hands. Dr. Mariam looked at this and wondered, wait a second, if a dead earth yields grain that sustains life, could a dead star yield organic molecules, like our PAHs, that literally act as the cosmic seeds for entirely new stellar systems?
To actually test this idea, she went through this fascinating technical process. It's almost like something out of a sci-fi movie. Step 1, she analyzed the intensity ratios of those infrared bands in the Orion Nebula. And she noticed something weird. They weren't random at all. They actually followed a logarithmic sequence. So, for step 2, she used what's called a Fourier transform. This basically takes those light frequencies and converts them into sound frequencies. And finally, step 3, she ran that through an audio sonification program to map the vibrational modes of the PAHs to actual sound. Now, you'd expect it to sound like random radio static, right? But it didn't. It produced this slow, rhythmic, seed-sowing sound that distinctly mirrored the structural phonetics of the Arabic word for grain, haba, and the phrase brought it to life.
Now here is the absolute kicker, 99.9. That is the staggering correlation she discovered. I mean, in data analysis, finding a 99.9% match between two completely unrelated sets of complex data, that's basically unheard of. The sonic wave envelope of the PAH infrared data matched the phonetic breathing, stopping, and extending sounds of the verses recitation with 99.9% accuracy. And taking it even further, Dr. Merriam projected this whole thing into a 3D molecular space. Her model revealed what she called a seed of life hologram, where the physical carbon ring structures mapped perfectly onto the linguistic spins and expansions of the text. Just wild.
Naturally, Dr. David was, skeptical. Who wouldn't be? He argued, look, this is just the normal size distribution of PAHs, nothing special. So, to prove her wrong, he built a computer-generated model. Actually, a synthetic pH model to be exact. It had the same number of rings, but with random side chains, and he ran the exact same sonification process. The result? Pure random hissing. There are absolutely no structural phonetics, zero. Dr. Mariam explained exactly why this happened.
You see, natural PAHs possess this highly specific vibrational symmetry called D6H molecular symmetry. It's this exact symmetry that governs the frequencies that create life-building patterns. Because David's synthetic model completely lacked this natural symmetry, it essentially proved that the interstellar PAHs were uniquely specifically structured. They weren't random at all.
But wait, the analysis went even deeper than that. Dr. Merriam started looking at the carbon to hydrogen, or C/H ratio of the PAHs. This ratio basically tells you how mature the molecule is. She found that the C/H ratio in the Orion Nebula perfectly matched the linguistic pattern for the concept of feeding or eating that was found in the text. David pushed back on this again. He tested this specific C/H ratio against data from 5 completely different nebula, including the Tarantula and Eagle Nebula. And guess what he found? That specific feeding pattern, it only existed in the Orion Nebula, which just so happens to be an active star-forming region. In dead regions, the pattern was just random noise. The molecules were literally structurally optimized to feed new stars.
Moving on to the next part of the versus framework, the gardens. Dr. Merriam analyzed the size distribution of these PAHs. She looked at everything: small molecules with maybe 20 carbons, massive chains of 50 or more, and mid-sized clusters in between. When she projected all of this into 3D space, the distribution matched the phonetic structure of gardens of date palms and vines, again with that 99.9% accuracy. The study suggests that the diverse sizes of these organic molecules function exactly like a lush biological garden in space, providing all the different building blocks you'd need for cosmic evolution.
Okay, but what about the springs mentioned in the text? Dr. Merriam dug into how PHAS interact with water vapor out in deep space. She discovered that the carbon-hydrogen bonds in PAHs create very specific intermolecular forces with the oxygen-hydrogen bonds in water. The exact bond energy of this interaction? It perfectly mirrored the linguistic structure for flowing springs. And when Dr. David went and tested this across 3 different water-rich cosmic regions, like Sagittarius B2 and W51, the pattern held up flawlessly. The pH molecule literally acts like a microspring, helping facilitate the flow of the very water that's necessary for life.
Next, she mapped all this organic production out over space and time. She tracked a star's age on the x-axis, PAH density on the y-axis, and infrared intensity on the z-axis, and found this incredibly distinct peak. The data showed that over millions of years, these molecules act as a kind of cosmic fruit. At 1 million years, you hit peak density. Around 5 million years, they're actively providing sustenance to newly born stars. And by 10 million years, they're out there seeding nascent planets. Dr. David tested this peak data across 10 different star birth regions, and every single one confirmed it. PAHs really do function as this nourishing cosmic fruit over their lifespan.
The final piece of Dr. Merriam's data puzzle focused on the sheer molecular complexity of these massive 20 to 100 carbon ring structures. The mathematical complexity required for these things to even form in the first place matched the linguistic pattern of the phrase "not made by their hands." It was this profound mathematical sign indicating that these incredibly complex, life-seeding molecules are not just the product of random, chaotic generation. They bear the hallmark of something deliberate, a natural, or divine, depending on your perspective, creation.
Dr. Merriam actually laid all this out at an international astrochemistry conference, and it basically looked like this table here. She maps the empirical data seamlessly straight to the text. The death of a star? That aligns with the dead Earth. The creation of natural PAHs? That aligns with the Earth being brought to life. The diverse size distribution of the molecules mirrors the gardens. And those specific intermolecular bonds between PAHs and water vapor, they perfectly map to the springs. It was this absolute seamless overlay of deep space infrared spectra and ancient linguistic structure.
Now here is the absolute best part of the whole story: Dr. David Thompson's reaction. Remember, this is the guy who started out as a staunch materialist. He saw PAHs as literally just chemical garbage. But after personally verifying the data across multiple nebulae himself and completely failing to recreate that symmetry synthetically, he stood up at the conference and delivered this exact quote. He conceded his strictly materialist viewpoint and openly admitted his new belief that the pH molecule acts as a structured, cosmic reality of bringing life from death. What a game changer.
And you know, this isn't just some concluded, dusty old study. It's a hugely active, real-world scientific endeavor. Right now, Dr. Merriam's lab is running what they call the Cosmic Seed Yasin project. They're actively out there analyzing 20 different nebula using the James Webb Space Telescope, specifically hunting for these exact sonification patterns to better understand how stellar nurseries operate. Plus, she's actually compiling all of this groundbreaking research into an upcoming book titled The Dust Sows. It's going to expand on how these organic molecules act as the literal seeds of the universe. In the source material, Dr. Merriam leaves us with this incredibly poetic yet profoundly scientifically grounded thought. She says, when you look at the stars, don't just think light, think grain. I mean, wow. It completely reorients your entire perspective. Every single photon we capture in our telescopes is accompanied by these complex organic structures. It's like this vast unseen harvest floating in the interstellar medium, continuously turning the death of old stars into the living, breathing gardens of entirely new worlds.
Which brings us to our final thought for today's explainer. Are we merely measuring the universe in microns, just cataloging random chemical interactions? Or is every speck of dust a highly structured seed just waiting to be understood? The data we've explored today strongly suggests that the universe might be far more beautifully organized and honestly, far more poetic than a purely random materialist view could ever capture. It really leaves you wondering, doesn't it? What other profound connections are out there, hiding right in front of our telescopes?